Hi everyone, and welcome to the Aircraft Certification channel. For who doesn't know me, I'm Clarissa Fedel, and together with Rafaela Caillaux, we create this space to share our experience with aircraft certification and allow other incredible professionals to do the same. So if you like aircraft development and certification, subscribe to our channel and click in the notifications button to be aware every time that we upload a new video. In today's video, Rafaela talks with Marcelo Almeida about system architecture. Marcelo explains what system architecture is and the difference with system engineering. They also talked about the perfect timing for engaging a system architect in a project, the main deliverables, and how it's related with the design assurance process. Marcelo explained the relation with the certification and also how it helps with the changing management and the continued airworthiness. At the end, Marcelo shares his thoughts about the future and how the system architecture is crucial for the development of the urban mobility concept, such as the UAVs and eVTOLs and all the related infrastructure. So welcome aboard and enjoy your journey.
Hello everyone, I'm Rafaela Caillaux and today I'm here with Marcelo Almeida, our system architect and also development assurance specialist. And we are here to talk about system architecture. So Marcelo, can you start introducing yourself to the audience?
Yeah, sure. So thanks for having me. It's a pleasure to be here and to contribute to your projects. Great talking to your audience and discussing system architecture. So I do have 14 years of experience working in the aerospace industry. My background is mechatronics engineer. I do have a specialization in aeronautics engineering. I have worked at defining processes, defining methods and tools that people use to define systems, to define system architecture, and to really put together certification cases for certifying aircraft, modification of aircraft, under FAA, under ANAC, under EASA. I have also a LinkedIn page where I do discuss system engineering concept, system architecture concept, and I would love to have your audience interacting and discussing those concepts with me using that link.
Okay, so please go to Marcelo's webpage too and share your ideas with him.
Thank you.
I would like to start this conversation talking about what really is system architecture and what's the main difference between system architecture and system engineering, because I think people have a lot of confusion about those two wordings.
Right. So, nice question. Thanks. So, system engineer is a deductive process. System engineer is about analytical tools, is about hard science, it's about mathematics, physics, it's about sizing and getting system ready for production, right? So when you do finish the detailed engineering phase, the system is ready to start production. We do have the production plans, we do have codes, we do have everything necessary to start production. Architecture, on the other hand, is an inductive process, is a creative process. It is about reducing ambiguity, is about creating a solution to a problem presented by a client, presented by a stakeholder, presented by a certification authority. It defines the organization principles of the systems. It defines what the pieces of the system are, how they connect together, how the functions are allocated to each system component. It is a highly creative task. That said, the architect is somebody that applies creativity, that applies varied methods like brainstorming, like the engineering experience to define, okay, if I need to solve a problem, that this is the problem. So if I put together these pieces, if I do allocate functions like this will solve the problem that is presented to me. It is different from the system engineer because it is not that based on hard science. It's based really on creativity. It's based on heavily on experience. It does take a lot of experience to create a good system architecture.
Okay, so what you're saying is that the system engineering is more a quantitative methodology where you're gonna dimension things, and the system architecture is more towards a qualitative assessment where you're gonna evaluate all the pieces, all the systems, and the information that they are going back and forth through them.
That's
right?
correct. Exactly like that. Exactly like that. Like engineering, at the end, for instance, the work of an engineer is to have a diagram that shows what the dimensions are for a given system. The architect, it does have like a block diagram that shows how the things connect, how the functions are allocated to each of the equipment parts. As you said, the real difference is how the level of details that are being worked on and the level of analysis that is being done, or the type of analysis being done, I should say.
Okay, and why is it important to document the system architecture?
Yeah, I like to think of system architecture as a set of organization principles. Today, the regulations do require us to deliver a certain number of features. The systems and the market do require us to have an ever increasing complex systems. In order to give you an example, a Boeing 787, it does have like 2 million parts and a lot of lines of code. So it is said, the 787 is said to have more than 10 million lines of code. So how do you manage that complexity? You need to have somebody working on defining the organization principles, defining the functions, and assigning tasks, assigning functions to the equipment, and defining how those pieces connect together.
Come together.
So documenting the system architecture and creating system architecture is a response to the increasing complexity of those systems and to the high rate of advances in computer and information sciences.
It seems like this activity is done more in the initial phases of the development. So when exactly is the system architecture created?
Right. So the system architecture is created at the conceptual definition phase.
Okay.
Right, where the pieces and the parts are defined, the interfaces are laid out and sketched or drafted. It is where at the conceptual definition phase is where the big slice of problems are created and the parts are assigned functions to it, the interface are defined. But the bulk, as I said, the bulk of the work is done during the design definition phase, the concept definition phase, sorry. But that is not the only job of the architect. As the job progresses during the detailed definition phase, it is the job of the architecture to be like a judge to really mediate discussions between conflicting systems, conflicting interfacing systems, and to ensure that the architecture that was taught up front is to protect and the intent of the architecture is met at the end of the design phase. When it comes to certification, to final delivery, it is the job of the system architect to look at the system, to look at everything that was done and say, okay, this system, the way it is built, the way it is assembled, it does define everything we need to deliver the value that the clients expect from us. So it is an evolving job, evolving task throughout the entire development. But as you said, highly focused a lot on the conceptual definition phase, where the big definitions are made, where the system performance is kind of defined.
And as we all know, you want to do the good decision. You make good decisions in the beginning of the process, not to be caught with a lot of problems in the end that
Right.
you need to rework to fix it, right?
Yeah, because at the end, a good system architecture is what gonna define, or well, it's gonna limit the performance that you can achieve in a system, right? It's not gonna define the performance, but it's gonna set the boundaries of what you can achieve with that system.
Okay, and what are the main deliverables of the system architect?
Right. So the system architect, among a lot of things, it does have to define a set of goals, including functional goals for the system, right? As we were discussing before, it does define what the system needs to do to really meet the client needs, to deliver value to the client. It defines the system context. It's the guy that does go ahead and studies how the system is going to be used and how the system interfaces with other systems. It defines the system concept, right? How the general way of assembling together the system, how it looks like. It defines how the system is going to be operated in a concept of operation. It also defines a functional description of the system that needs to go down at least 2 layers. It defines the decomposition of form, so the composition of function and form, and it details the external interfaces and also the interface control. So how are you going to change, if any, and what is the process that you are going to use to change interfaces? And at the end, it also provides a notional development cost, a schedule, and risks. Because the system architect, one of the main things that he's concerned about is how risky is this development? Can I achieve it without risking the business?
Okay, so when you mention, it seems like it's a very broad scope, but you mentioned that you at least have to evaluate 2 layers. So what do you mean by those 2 layers?
Right. One of the tools that the system architecture uses to create a solution to a problem is a abstraction, right? One of the abstractions that a architect can use is slicing the problem into layers, like a layer 0, a layer 1, a layer 2. Those layers are the difference between layer 0 and layer 1 is that the layer 0 is a higher level description of the system or a higher level of the architecture of the system, whereas the layer 1 is a lower one. Think of it like a state is layer 0, then you have cities, then you have neighborhoods, like each one of those a different layer, a different level of details. If we transport that to aircraft, it is layer 0, we could say layer 0 is the aircraft, layer 1 is the system,
Okay.
then layer 2 are the equipment, layer 3, software and airborne electronic hardware. So it is essentially like different levels of abstraction. Use it as a tool by the architect to really describe the solution in a way that the stakeholders can understand and that the system can be maintained and properly implemented.
Okay, so in the aircraft, it would be like the aircraft, you're evaluating the scope or the problem in the aircraft level, and then you need at least to do the aircraft level and the systems level to gather all the information that you need
Right.
to perform your work.
Right. If we think about the architecture, the aircraft, like the function of the aircraft is to move people from point A to point B.
Okay.
Then in order to move people from point A to point B, you need to have a communication system in the aircraft because the aircraft needs to be able to talk to the air traffic control, to other aircraft. In addition to that, depending on the solution, right, you may need a fuel system or you may need a battery system.
Mm-hmm.
Right, so that second
Okay.
level is necessary for you to really start to lay down the architecture, the components, and how those things connect together, and what the dependencies are between those points, those
But
aspects.
it seems like this is valid not only for an aircraft, but also for system development or for a component development.
The idea is applicable at any level of abstraction. As I said, at the software level, for instance, the 0178 defines in the letter of the law that you need to have a high level requirement, you need to have a design definition. Design definition is composed basically of low level requirement and the architecture.
Okay.
The architecture is a response, in this case, to the high level requirements, which are defining what the software needs to do. So it is in the letter of the law that you need to do that for the software level. It's the same thing for hardware. So it's essentially applicable for any level of abstraction that you may want to use that.
Okay, so I was gonna ask you about certification, but I'm gonna hold this question for a little bit. And I would like to know, how do you produce those deliverables in the development?
Right. The system architecture is about reducing ambiguity and managing risks. At the beginning of any project, all that you have is a lot of questions, a lot of wishes, and a lot of possibilities. You need to funnel down those possibilities to something that you can actually implement. So the system architecture uses several methods, like we were talking before. He can use abstraction, he can use like brainstorming, and he does rely a lot on previous experience. So this is why a good system architect is also a highly experienced system architect or system engineer, right? It's somebody that does have seen a lot of things before and that understand how things can be put together to solve similar classes of problems. Like architecture is just like engineering, which is about identifying similarities, identify classes, identifying similar things that can be put together maybe into another environment, into another scenario to solve similar problems.
Seems like you have a lot of freedom in this beginning to define how you're going to work. But it is a structured process, right? So how do you...
Because at the end, a good system architecture process creates deliverables, documents those decisions, and make it available for all the future users and stakeholders to check it and to study and to learn from previous experience and from what you've done. What were the decisions, how the system was laid out, how the system was put together, because that is what is important in the system architecture. You need to understand, you need to be able to really look into it and understand what are the principles behind that architecture.
Okay, so that's what certification loves also. Now going deeper on the certification, are there any specific certification requirements to drive this activity, or how is it related to design assurance level? And...
Right. There are some, but there is one specific requirement that is pretty generic. That requirement asks, you need to prove that the system functions as intended. It's 1309A and 1301 kind of touches on that, but more 1309A. Then it also requires us to demonstrate that if a system fails, that it does not affect critical systems, other critical systems. So how do you go about proving it? If you have a complex and complicated system, it's going to be an impossible job for you to do. On the other hand, if you have a complex system, but that is not complicated, that is well organized, that there are a set of leading principles that were used to put the system together, it's going to make your job easier to analyze that system and to show, to prove and convincing the other side, the certification authority, that what you're doing is really putting together a system that will function as intended when operated in the environmental and operational conditions that you plan, that you design your system to.
Okay, so it seems like it has a lot of activities to document and to keep the traceability of how the decisions are made throughout the process, right?
That is key. You need to put traceability, you need to document assumptions, you need to document rationale, so that you do have that. It's almost like a description of what you're doing.
Okay, like a memoir
of the decisions you've made.
Okay, good.
And in that sense, we do usually have system description, right? I've seen a lot of places where the system description is created just at the end. But the system description can be a pretty much living document that starts with the conceptual definition, then it goes being updated with details as those details are
as the
details are defined. But it is a fundamental understanding, a fundamental piece of information that can help understanding what the system is, right? Put together a system description that defines what the components are, what the functions are, how those interface together, and how those interface with the outside world. So that is fundamental and of interest for all the parts that are designing a huge complex system like an aircraft, with a lot of moving parts being developed together, being developed at the same time.
And how is this related to the design assurance level or to the design assurance activity?
Right. So system architecture, it is an input for safety system, and it is one of the deliverables of the development assurance process. As an input to the safety assessment, safety assessment takes that, analyzes it, and defines the level of rigor that needs to be applied to V&V that system, to validate and verify the system, to validate and verify the requirements. That level of rigor is then fed back into the development assurance process, and it is used to validate requirements, to verify the implementation, and to perform all the activities related to development assurance with the appropriate level of rigor, which is based on the safety analysis. Like catastrophic, a system that has a catastrophic failure event on it will have to be developed according to the highest level of rigor for validation, for verification. That is the connection. Architecture is the glue that connects together development assurance, safety, also not to mention like security, and now security, now those ELDs that are necessary for creating a good system.
Okay, so it's kind of an input for all the design assurance and the safety assessment. Okay, and now with the new models coming up, and how do you see the future of the system architecture?
The big trend in system architecture moves towards a model-based system architecture, and which consists of creating an architecture like a big data set. A data set that can be queried, that can be interrogated to identify whatever aspect of the architecture that is of interest to you. So to give you an example, well, let's say that you do have an architecture that a diagram or a model that describes allocation of function to a system. So then you can understand what functions are allocated to what systems. You can interrogate the model to say, okay, so bring to me the list of systems that do not have any function allocated to it. It also helps you throughout the development, managing the development and defining, okay, so these are the next steps that I need to take in order to achieve the goal at the end.
Okay, to find information easily. And what about artificial intelligence? How does it can help in this process? Because it seems like it can add.
I'm not an artificial intelligence specialist. I may be a little bit beyond my skill here, but the way I understand artificial intelligence, it is about recognizing patterns and creating new patterns by combining those patterns to achieve something better, right? So in that sense, a huge database of architecture could be used to create new combinations, could be used to create new functions based on combinations that were not available before, that were not used before. I have not seen that used, but I see that as a possible use in the future.
In the future.
Right.
Okay. Yeah. Maybe we're a little behind that yet, but maybe.
or our knowledge is a little bit behind. Right?
Yeah. Okay, Marcelo. So could you summarize the main benefits of system architecture, using system architecture in the beginning of the process?
Right. So system architecture is, you can think of system architecture as the enabler of system performance. When you put together a system architecture, you are defining the boundaries of the performance that your system can achieve. There is no good component that will solve a poorly architected system, right? The performance problems of poorly architected system. When you are doing system architecture at the beginning, you are defining and embedding safety concept, you are embedding the reliability, you are embedding the security, and you are embedding the scalability. Think of a good system architecture done at the beginning of the system sets you into the path for success. Because especially on airspace, where the projects range from 5 to 10 years, and change is a constant, update is a constant thing, you need to create a system architecture at the beginning that really allows you to have that mindset of constant evolution while minimizing the impacts on parts that are more stable and not changing that much. If you do that at the beginning, chances are that you're gonna be able to do that since the beginning. If you do not do that and you think about architecture as an afterthought, you're gonna probably create a system that is pretty much like a patchwork. Think like if you create your house without an architecture plan. At the end, you're probably gonna have a house, you're gonna have a roof to live, but it's gonna look like a patchwork with a lot of pieces glued together that were not really thought through. And creating that at the end will result into delays and will result in budget overruns when the inevitable happens, when you have to change because something happened, because the system context changed, because the user changed, because whatever changed, and that is a constant. That is something that you're gonna have to deal with.
Yeah, so it seems like it's very useful also for after the development when the aircraft is now being operated. So for the continued airworthiness stage, where the aircraft will be subject to changes, as you mentioned, and now you have some kind of a documented process where you can go back and look what's gonna happen, how is this change going to affect your system and other systems, right?
Yeah, I always remember of a piece of software that I used to work with where people would do all they could to not touch it because it was such
like a black box that no one's wants to mess with it.
Such a node software that nobody really understood its architecture. Nobody really understood it deeply how it works. So there is a saying in English that people say, if it is working, don't change it.
Okay.
Don't touch it. Don't touch it. Leave it there. Leave it there. Don't touch it.
If you're not sure about the effects of this change, don't mess with it.
Because if you go ahead and change and then you fix something but it breaks something else, that is a domino effect. Then you go there and you fix that and that touches something else and then blah. So that's a domino effect. You don't know how that will stop, and that will result in the end in budget overruns and delays and may even lead to project cancellation. And nobody wants that.
Nobody wants that. Nobody wants to have big surprises in the end of a design process.
Yeah. And then you've mentioned that a lot when we were talking about decertification, right? When you have a good documented architecture, it makes the life of whoever is trying to certify a system way easier because it is easier to explain. It is easier to put together a case to show to the certification authorities that the system is safe and that it was developed in a organized, thoughtful way. That
it's
really,
reliable.
It's reliable, that it leads to a system that is maybe complex, but it's not overly complicated so that nobody can analyze it and really be sure that it is safe for flights.
Okay. All right. So I would like also to do our final question about the eVTOLs. So a lot of companies are now developing new aircraft for urban air mobility. And how does system architecture can help these developments?
Yeah, this UAM initiative is a huge exercise of system architecture. Because if we think about what is going on right now, there are a lot of new services being created. So there is a new vehicle concepts being created, new infrastructure being created, new so many things that it is even hard to envision how the future is gonna look like.
Yeah, you're right. So what's gonna be? It's unknown yet.
So that takes a good system architect or a good team of system architects or a good maybe collaborative effort to show us what that future looks like now by creating an architecture, by creating the concepts, by doing demonstrations. So that takes a lot of architecture, takes a lot of creativity, takes a lot of talk to the customers, a lot of talk to the stakeholders, so that we can really envision and really be able to see the future now. And that is the job of architecture, show us what is possible in the future now.
Okay. And it's interesting because I was in a speech given by Skydrive, which is a Japanese company that's developing a vehicle like this, and they were saying that they were planning to use all the convenience stores that are spread all over the country to park those vehicles. Actually, the parking lots should be able to be transformed in a takeoff and landing. So it's a eVTOL port.
Right.
And it's very interesting because it's not implemented yet, but you can already envision how it's going to work.
Yeah.
So
And that is interesting, right? And to be honest, when I think about what is going on with VTOLs, what is going on with autonomous vehicles, I think that may be an intermediate step, like that is feasible in a near future. But at the end, are we even going to need parking lots, right? Because at the end, we're gonna have robots, we're gonna have new services, right? So I do see a future where I do my grocery shopping in an app. That app commands a robot car to go to that grocery shop store, to the grocery store, and then a robot-sized something delivers that to the car, and the car brings that back to me. So,
or even for this vehicle, right?
for this
Yeah.
vehicle, whatever the mean of transportation, right? We don't know. So it is the job now of the architecture to create, to give us a taste of what that looks like, so that we can actually make it possible, make that happen. Because it's going to take a lot of money, it's going to take a lot of effort, it's going to take a lot of new tasks. For instance, certification is going to be different.
Yeah.
Right? It's going to require a lot of infrastructure, right? Do we need like a centralized air traffic control, or maybe ground traffic control?
Yeah.
Do we need
we don't know yet.
The UAM concept envisioned by NASA, it talks about a automated air traffic control, because of the number of players on this new air space, right? So it is not controllable by humans. We were talking about before how architects uses abstraction, right, to simplify and to communicate their ideas. So this is going to require another level of abstraction. The number of vehicles that is expected to be flying is so high that it's not possible for a human to control that.
Control it, yeah.
It is already overwhelming today for the air traffic controllers to control the current air traffic.
Yeah.
Put together that many, the more automated vehicles you have on the road, the more or the bigger is going to be the need for a centralized controlling traffic or something. I think so.
Okay, so Marcelo, I would really like to thank you a lot for sharing your thoughts and your vision of the future with us. We don't know what the future reserves us, but we know it's very exciting, and there's a lot of changes coming up in the next, 10 or 20 years from now.
The exciting times are coming. We are up for the challenge, and I think human has proven that can do amazing things, and I think we will continue to do so.
Okay, so thanks a lot, and I hope to see you here again.
It was a pleasure.
If you want to contact Marcelo, his contact is in the description area. Thanks for watching, and enjoy your journey. Okay, Marcelo, so thanks a lot for being here with us. Hope to see you again.